A sequence is linear if it increases or decreases in equal steps. This first sequence is linear because it decreases by 9 each time. The second sequence is linear because it increases by 3 each time. Every linear sequence has a position to term rule, and this rule tells us how to work out any term in the sequence. For this first sequence, the position to term rule is 99 minus 9n. So if I wanted to work out the fourth term, which I know is 63, I would do 99 minus 9 times 4. So I would replace the n with 4 because I'm looking for my fourth term. So I'll have 99 minus 36 because 9 times 4 is 36, which will give me 63, which I know is my answer. It is important to note that the n represents the position of the term in the sequence, so we call this general rule the nth term. But why is this useful? Well, if I wanted to work out the seventh term, I could just subtract 9 from 45, and I'll get 36, which is really easy. But what if I wanted to work out the 100th term? Well, instead I can use my formula. I can replace my n with 100. So I will have 99 minus 9 times 100. I know 9 times 100 is 900, so I've got 99 minus 900. Now be careful because this does give us a negative answer. 99 minus 900 gives us minus 801, which seems right because if we're decreasing by 9 each time, and we do this 100 times, we expect our answer to be negative. And this is a lot easier than writing out our entire sequence. Let's have a look at this for our second example. Well, our position to term rule, or our nth term, is going to be 3n minus 2. Now we're not going to look at how to work out the nth term just yet. Let's check if this works. Let's try it for our third term. Well, if I replace n with 3, I'll end up with 3 times 3 minus 2. 3 times 3 is 9, minus 2 gives us 7, and our third term is 7. So we know this is correct. So what would we get for our 100th term? Well, let's replace n with 100. So for term 100, I will get 3 times 100 minus 2. 3 times 100 is 300, and minus 2 is 298. So my 100th term is 298. In this video, we're going to focus on working out the position to term rule. In other words, we're going to look at working out the nth term. If we have a sequence where the first 4 terms are 1, 4, 7, and 10, the first thing we need to do is check that this is linear. And to do that, you may need to work out the term-to-term rule. The term-to-term rule is just the rule that takes us from one term to the next. So in this case, to get from 1 to 4, we're adding 3. And then to get from 4 to 7, we're adding 3. And then again, to get from 7 to 10, we're adding 3. It's really important that this term-to-term rule is consistent throughout the whole sequence, so we know it's linear. Once we have our term-to-term rule, we're just going to set up a little table. The first row of this table is just going to tell us what term we're looking at, so we're going to label this n. And in this case, we have 4 terms, so we're going to have our first, second, third, and fourth labelled in each of these columns. Our second row is just going to be our sequence, so our original sequence will go here. In this case, our terms are 1, 4, 7, and 10. Our next row is what our sequence starts off with. Now, because our term-to-term rule is plus 3, our sequence is going to start off with 3n. Let's work out what 3n is for each of these columns. Well, in the second column, n is 1, so 3n will be 3 times 1, which is 3. In our next column, n is 2, so 3n will be 3 times 2, which is 6. And then our next column, our n is 3, and 3 times 3 is 9. And then finally, n is 4, and 3 times 4 is 12. Our last row will just be our original sequence, and we're going to take away this piece of the sequence that we've just found. So we're going to take away 3n from our original sequence. 1 minus 3 is minus 2. 4 minus 6 is minus 2 as well. 7 minus 9 is minus 2, and so is 10 minus 12. For a linear sequence, this last row should always have the same value. If it doesn't have the same value, we know we've done something wrong. Or maybe our sequence isn't actually linear, so we need to double check our first step, where we're working out the term-to-term rule. Now, to put our nth term together, we take what our sequence started with, so our nth term will start with 3n, and then because our value that we got at the end was minus 2, we're just going to put minus 2 at the end. So our nth term is 3n minus 2. This is our position to term rule. And just to check if this works, well, what happens when I want to work out my third term? So t brackets 3. Well, I'm going to replace that n with 3. So I've got 3 times 3 is 9, minus 2 is 7. And if I look back at my original sequence, my third term was 7. So this nth term is definitely correct. Let's have a look at a second example. What if instead our sequence was 6, 10, 14, and 18? The first thing we need to do is find our term-to-term rule, and in this case, we're adding 4 each time. So our term-to-term rule is plus 4. Our next step would be to set up our table. Our first row is n, so we'll have our first, second, third, and fourth term. Then we'll put our original sequence, which was 6, 10, 14, and 18. This time, my nth term was plus 4, so my sequence is going to start with 4n. So to fill in this column, we're going to, because n is 1, we're going to do 4 times 1. Then n is 2, so we're going to do 4 times 2, then 4 times 3, and then 4 times 4. And our final step and our final row is to do our subtraction. So we're taking our original and we're subtracting the first part of our sequence, which was 4n. 6 minus 4 is 2, and it's positive, so I'm going to write plus 2. 10 minus 8 is also 2, so is 14 minus 12, and 18 minus 16. Because these are all the same, I know that I am doing this correct, and it is a linear sequence. Let's put our answer together. So our nth term started with 4n, and then we have plus 2. So our nth term is 4n plus 2. It's nice to do a check just to make sure it works. This time I'm going to check it for the fourth term. So if we're trying to work out our fourth term, so t bracket 4, we're going to replace n with 4. So 4 times 4 is 16, plus 2 is 18. So yes, this does work. So this is correct. The key thing to remember is to always check that your sequence is linear before you start. Because if it's not linear, then you can't do all of these things to work out the position to term rule. The next thing is, in a question, they could call it the nth term, they could call it the position to term rule, or they could just say general rule. All of these things mean the same thing. They want you to work out the expression that helps determine the position to term rule. And lastly, don't forget to do your check. It's an easy way to see whether you've got the question right or wrong. But when you do a check, make it really clear what your actual answer is. So I've used a highlighter to do that. In an exam, they will have a dotted line where you can write your final answer.